That hair is an appendage of the skin, chiefly composed of a protein called keratin. All right? Hair is clearly defined by two main divisions, the root and the shaft. The root are the underlying structures responsible for the growth and the regeneration of hair. The shaft is the outgrowth that you see on the scalp. All right? The structures of your hair root are your follicle, your bulb, your dermal papilla, your sebaceous glands, and your erector pili muscles. Your follicle is the tube-like depression or pocket in the skin, sinks from the epidermis down into the terminus. It encases the hair root. All right. The hair bulb is the club-shaped structure that encases the lower part of the hair root, covers the dermal papilla. All right. Now, dermal papilla itself, that supplies the nourishment, the blood flow to the hair. All right, responsible for giving it its nourishment to continually grow. All right, now dermal papilla contains blood and nerve supply. All right, please, you know, go ahead. Sebaceous glands. Our sebaceous glands are ducts connected to our hair follicle that dump sebum that keeps our hair soft and pliable, keeps our skin moist. All right? And last but not least, our erector pili muscles, involuntary muscles connected to the follicle. When they contract, it gives you goosebumps, hair stands on the end. All right? Now, the hair shaft consists of three layers: the cuticle, the cortex, and the medulla. All right? The cuticle is the outermost layer of the hair shaft. All right? It's a single overlapping layer of transparent scales. Each individual scale is attached to the cortex. All right? The cuticle is affected by changes in pH. All right? The cortex is the middle layer. All right? It's the protein core. Everything that's happening in the hair is happening in the cortex. That cortex is responsible for about 90% of the total weight of your hair. All right? And it gives the hair its strength, its flexibility, and its elasticity. All right? Last but not least, the innermost layer is the medulla. Well, maybe least. The medulla is the innermost layer. All right? It's composed of round cells, and in some types of hair, the medulla is absent. Fine hair, naturally blonde hairs. All right, let's talk about the chemical composition of hair. If you want to thoroughly understand chemical texture services and hair color services, you must understand the chemical composition of hair, how it's made up, and how those services affect this chemical makeup. All right? So hair is approximately 90% protein, right? Protein. What is that protein called? Keratin, right? Now that protein is made up of long chains of amino acid. That amino acid is made up of elements. All right? So protein is made up of amino acid. Amino acid is made up of elements: carbon, oxygen, hydrogen, nitrogen, and sulfur. These are the elements that make the amino acid, that make the protein that is the hair that you see. Let's talk about bonds. All right, I heard you mention cross bonds. Let's talk about our end bonds first. Peptide bonds, also known as end bonds. All right, our proteins, remember we just said our proteins are chains of amino acid. Those chains of amino acid are joined together end to end by peptide bonds or end bonds. All right? When that chain is joined, it creates what's called a polypeptide chain. Bonds, right? End to end. All right? End bonds, peptide chains. Now, those are strong chemical bonds that cannot be reformed. They can be broken when you cut them. They can be broken with chemical depilatories, right? But once the end bonds are broken, they dissolve. They cannot be reformed. All right? Now let's talk about our side bonds. Those polypeptide chains that are joined end to end by peptide bonds are cross-linked side by side by our side bonds, right? Hydrogen, salt, disulfide. Hydrogen, salt, disulfide. Those are our side bonds. Hydrogen bond. My hydrogen bond is a weak physical bond. It's considered a weak physical bond. It is easily broken by heat or water. All right? Hydrogen bonds are reformed by drying or cooling. All right? Hydrogen bond, weak physical, broken by heat or water, reformed by drying or cooling. Right? I got that. Next is my salt bond. Also a weak physical bond. All right? It is broken by changes in pH and is reformed by normalizing pH. All right? Salt bond, weak physical bond, broken by changes in pH, reformed by normalizing the pH. And last but not least are the sulfide bonds, also known as sulfur bonds. All right? Now, these are the ones you need to pay the closest attention to because these are our strong chemical bonds. The sulfide bonds are our strong chemical bonds, which means they're not easily broken by heat or water like our hydrogen bond or simply by changes in pH like our salt bond. They're broken through chemical processes. So that's why this bond is so important and you need to understand it, all right, if you're going to be doing chemical texture services. All right, strong chemical bonds of the sulfide or sulfur bond is broken by thioperms or relaxers. All right, you can break your chemical bond with a thioperm or relaxer. Now, when using a thioperm or relaxer, you reform the bond by oxidation, neutralizing, right? That's how you reform the bonds when you've given a thio-relaxer. Now, when giving a hydroxide relaxer, this is important, you need to understand this because you could see this in the form of a question. Given a hydroxide relaxer, that bond cannot be reformed, right? Those bonds are converted into what's called lanthanide bonds, right? Water converts those bonds into lanthanide bonds, all right? Extreme heat can break your disulfide bonds. Once again, they cannot be converted, they cannot be reformed. Either they are converted into lanthanide bonds, all right? So that's your cross bond, your side bonds. Hydrogen, salt, disulfide. Hydrogen, weak physical. Salt, weak physical. Disulfide, strong chemical. All right? You need to understand that about the bonds in the air. Peptide, end bonds, strong chemical bond. All right? Now, let's talk about hair pigment. Hair pigment, natural hair color, is a result of melanin pigment found in the cortex. Right? You have eumelanin, you have pheomelanin. Eumelanin turns your hair black and brown. Pheomelanin turns your hair yellow, blonde, and red colors. Right? Now the result of the natural hair color that you see is a combination of the thickness of your hair, along with the number and size of those pigment granules, and the ratio of eumelanin to pheomelanin. All right? Everybody get that? That's pigment, melanin. Wave pattern. Wave pattern. Now, wave pattern is often mischaracterized as texture by untrained professionals. Wave pattern is the shape of the hair strand or the amount of movement in the hair strand. Straight, wavy, curly, coily, etc. That's wave pattern. That's not texture. Everybody get that? The amount of curve, the amount of wave, how straight, that's wave pattern. Types of hair. Types of hair. This is definition. You understand you got two types of hair on your body, on your head. You have what's called vellus hair. Vellus or lanugo. That's the short, fine hair, downy hair. You ever see a person with that real light downy hair on their forehead? Ever see a person with, they have that light hair, it has no color, it just looks like peach fuzz. The people commonly call it peach fuzz. Or that baby hair. That's vellus hair. Also have what's called terminal hair. Terminal hair is the long, coarse hair, right? That's all over your body. At any given time, your hair can be in one of three growth cycles. right? Your hair grows in cycles. And that's 3 growth cycles, 3 phases. You have what's called the anagen phase. The anagen phase is the growth phase. In this phase, this is where new hair grows, right? Now, you have the catagen phase. The catagen phase is the transitional phase from the growth phase to what's known as the resting or the telogen phase, right? In the telogen phase, hair sheds or falls off and make room for new hair to grow. It either sheds or it's either pushed out by hair that is now growing once that follicle converts back to the anagen phase. It's normal to shed 75 to 100 hairs per day. But I might throw that note in for you. It is normal to shed 75 to 100 hairs per day. If you're shedding more, that may be evidence that something's wrong. All right? Let's talk about growth patterns. Growth patterns. You're going to need to be able to identify these growth patterns, especially in hair cutting, because it's a change in the behavior of the hair. And so you're going to change how you're going to get that result, right? You have hair stream. A hair stream is hair that flows in the same direction. All right? It's possible to have many different hair streams all over the head. When the stream changes, that's a reference point, right? A change in the behavior of the hair, reference point. But streams are hair that flows in the same direction. A whirl is hair that grows in a circular or swirl pattern, most commonly found in most people's crown, right? But it's not unusual to have whirls anywhere on the head. You will see that. You will see whirls on the hairline. You will see cowlicks on the hairline. And a cowlick is a tuft of hair that stands straight up, since I mentioned it. Alfalfa, straight up cowlick. Hair loss. The technical term for abnormal hair loss is alopecia. Hair loss treatments. All right? There are 2 hair loss treatments that are approved by the FDA. There are 2 hair loss treatments approved by the FDA. Minoxidil and finasteride. Minoxidil is a topical, it's over the counter, marketed more time, mainly as Rogaine, and finasteride is prescribed medication. All right, this chapter also talks about fungal infections. You need to be able to identify these in the shop if you're working as a barber. Our common fungal infections are going to be Actinium barbae, which is known as barber's itch, and Actinium crepidis. These are ringworms. Tinea. Tinea is a technical term for ringworm. Parasitic infections. You'll be able to identify parasitic infections, organisms, and the parasites are organisms that grow and feed, shelter on the inside of the organisms, giving nothing to the host organism in return. Parasitic infections that barbers must concern themselves with or look out for are going to be head lice and scabies. Bacterial infections. Bacterial infection. Folliculitis barbae, also known as barber's itch. All right, this is an infection of the bearded area characterized by pustules in the beard area, right? Now, with folliculitis barbae, the hair could grow through the pustules, all right? So notice the difference between folliculitis and pseudofolliculitis, because that's 2 separate terms. Folliculitis is barber's itch, pustules, hair grows through, right? Pseudofolliculitis, razor bumps, hairs under the skin, ingrown hairs. Pseudofolliculitis, ingrown hairs under the skin. Folliculitis, barber's itch, pseudo, razor bumps. Now, the difference between those 2 terms, if you don't get crossed up in a test, all right? Hair analysis. Tell you what, in here I'm not going to, because this is in more than 1 chapter. You're going to see this in a few chapters, right? Texture, density, porosity, and elasticity. You should be able to identify hair texture. Hair texture is defined as the diameter of an individual hair strand, characterized as coarse, fine, or medium. All right? The bigger the strand, the more coarse. The smaller, the more fine. Density, the number of hairs per square inch on the scalp. Think about a forest. The more trees, the more dense. The less trees, the less dense. Porosity, elasticity. Porosity is the ability to absorb moisture. Right? Now, porosity is more of a factor in our processes, not necessarily our hair cutting, but our chemical processes, our color processes, because porosity, being the ability to absorb moisture, means it's going to affect what? Come on, say it out loud. Processing time. The more porous, the quicker it's going to absorb. Less processing time. All right? Elasticity is the hair's ability to stretch and return without breaking. Which one of my chemical services does elasticity play a big part in? Permanent. Absolutely right. Right. How does elasticity affect those perm rods? Come on, you there. You right there.
Making the curves?
What about, that's absolutely right. How does it affect that curve?
Like how long you're supposed to like have it?
How tight the curl, like spiral, like how
The more elastic the hair,
Yeah.
the stronger the curl is going to be. That's absolutely right. And the longer that curl is going to hold. That's absolutely right. All right. So look, man, good job.